All right, so we're going to really jump into the deep end with stoichiometry here and start by, instead of looking at starting with moles of reactants or products, let's start with mass. And again, the key thing that you always keep in the back of your mind is get to moles. So in this first problem, it asks us what mass of iron, Fe, can be produced from 2 grams of iron 3 oxide. All right, so here's a balanced equation. And what I want you to do is label these like A and B. And the reason I want you to do that is because the key thing we want to figure out is we want to go from moles of A to moles of B. Now, I'm not given any moles of anything. I'm given grams of A. So how do I get to moles of A? I'm going to use the molar mass. How am I going to go from A to B? I'm going to use the coefficients from the balanced equation. And how am I going to go from moles of B to grams of B? I'll use the molar mass. So now that we have a kind of a plan here, let's put this into action using our conversion factors. So again, we're going to get to moles. I start with what I'm given. I got 2 grams of Fe2O3, and I want to get to moles of that first. So I'm going to use the molar mass. All right, so the problem's giving it to you, the 159.7, but just in case, make sure you know how to calculate that. So grams cancel out. Notice what unit I'm in now. I'm in moles of Fe2O3. That's my A. How do I get to moles of B? I'm going to use the coefficients from the balanced equation. That equation says 1 mole of Fe2O3 produces 2 moles of iron. Notice my moles cancel out. The unit I'm left with is moles of Fe. I'm almost there because I'm not going to stop at moles. The question asks what mass. So I'm going to use the molar mass of iron. Iron has a molar mass of 55.85 grams per 1 mole. And notice if I've set this up correctly, every single unit cancels out until I'm left with grams of iron, which is exactly what the problem is asking me for. So I'm going to toss this into my calculator, keeping track of significant figures. And that's going to produce 1.40 grams of iron. Now you might ask, well, what about the aluminum or the aluminum oxide? If the problem doesn't mention them, then we don't care. We are not finding anything out about them. In our next day of lectures, we'll start incorporating the other reactants when we talk about, well, what happens if we don't have enough moles? What happens to the reaction? So we'll get to that. All right, let's look at one more. So what mass of oxygen will react with octane based on the balanced equation? I'm going to write it up here because I'm out of space. But here's the balanced equation for this. We're going to take octane and we're going to burn it in the presence of oxygen. Remember, we talked about combustion reactions in our previous unit. And that's going to produce carbon dioxide and water. So this question is asking us for what mass of oxygen will react with 702 grams of octane. So what we're given, we're going to just call that A. And what we want to go to is B. You say, what about the products? The question didn't ask us about the products. So we're not even going to worry about it. So let's start with what we're given. Given 702 grams of octane. And the key thing is get to moles. Right? Well, let me give you the molar mass of the pertinent things. So the molar mass of octane is 114.23 grams per mole. And we'll probably need the molar mass of oxygen. That's 31.998 grams per mole. So I'm going to use the molar mass of octane. And notice here I've gotten to moles. Now, that's the key thing, get to moles. Now, how do I get to oxygen? Well, the only thing that relates octane to oxygen is the balanced equation. The balanced equation says 2 moles of octane has to react with 25 moles of oxygen. And notice I've gotten to moles of B. Finally, how do I get to grams? Again, I'll use the molar mass. 1 mole of oxygen weighs 31.998 grams. If I've done this correctly and set it up right, I'm ending on the unit that I want to go to. What mass of oxygen? I've gotten the grams of oxygen here. So now I'm just going to toss this in the calculator, keep track of my significant figures, and I get to 2,460 grams of oxygen. If you want to put it in scientific notation, let's practice that. 2.46 times 10 to the third grams of oxygen. All right, in the next lecture, I will talk about how do we deal with solutions and concentration.